Folks, this is a second video in what are called homogeneous substitutions. I explained that term in a previous video. So I'd like to just jump into this one. So if I go ahead and isolate the derivative term, the derivative expression, we get dy dx is equal to 4x squared plus 3y squared all over 2xy. I can go ahead and divide this 2xy into both terms in the numerator. This gives me that dy dx is equal to 2x over y plus 3y over 2x when I do that division. Let's clean that up one more time, make it a little easier to see our substitution. So I get that that's 2 times x over y plus 3 halves times y over x. And remember, the general trick for these homogeneous equations is to let v equal y over x. Okay. The consequence of that, let's go ahead and solve that for y. That gives us that y is equal to vx. So a consequence of that is that dy dx is equal to, and over here I'm going to do a product rule. We get that dy dx is equal to the first times the derivative of the second plus the second times the derivative of the first. Well, that simplifies to 1. Okay. The other thing is I'm going to replace, see this expression right here, I'm going to replace that with v is equal to y over x. Here I've got an x over y. So the other thing we have to notice is that if v is equal to y over x, that implies that 1 over v is equal to x over y, inverting. So let's go ahead and do our substitutions. In place of dy dx, I'm putting v plus x dv dx. That's equal to 2, and then in place of x over y, I'm putting 1 over v plus 3 halves, and then in place of y over x, I'm putting v. So what could we do here? Well, let's first subtract this v over to the other side. So this gives me x dv dx is equal to 2 over v. If I subtract this, this is going to give me plus 1/2 v. Well, let's see, what else can we do? Well, let's see if we can go ahead and combine these two as a single fraction. Remember, the purpose of this substitution is to give us a separable equation. So let's see here, if I want to add together these two fractions, and it might be helpful to think of this as v over 2. So I need a common denominator of 2v. So I'm going to multiply, I'm going to say that's equal to 4 over 2v plus v squared over 2v. So now we can write that as a single fraction. On the right hand side, we have v squared plus 4 over 2v. Now we can go ahead and divide this x over, so this gives us that dv dx is equal to v squared plus 4 over 2v times 1 over x. So now it should be clear that we've achieved our goal through the substitution. Remember, the purpose of substitution, when we let v equal y over x, is to take this, in this case it's a very nonlinear first order ODE, but it wasn't separable either. And now it is written in separable form. So we can go ahead and separate the variables, giving us that 2v over v squared plus 4 dv is equal to 1 over x dx. We now integrate both sides. Notice that this could be done with the u substitution. It's a perfect u substitution. So this gives us the integral of 1 over u du is equal to the integral of 1 over x dx. For the natural log of the absolute value of u is equal to the natural log of the absolute value of x plus c. or u, we've done this trick a few times, so I'm just going to do it. U is equal to c u is equal to c times x. Okay. So we have that u is equal to c times x, but u wasn't the variable we were asked to solve for. No. So we have to, in this case, back substitute to write u in terms of v. Okay. Well, we're not done even yet, because v wasn't our variable either. So in this case we had two substitutions. What was v? V was y over x. So we end up with y over x quantity squared plus 4 is equal to cx. I'm perfectly happy leaving the answer there in this implicit form. We could give the answer explicitly, and if we did so, we get y squared over x squared plus 4 is equal to cx, or that y squared over x squared is equal to cx minus 4, or that y squared is equal to cx cubed minus 4x squared. This is again an implicit solution. Maybe it's a better implicit solution than our first option. So maybe we could park our answer here. Or if you like, we could say y1 of x is equal to the positive square root of cx cubed minus 4x squared. And y2 of x is equal to the negative square root of cx cubed minus 4x squared. And this is the explicit solutions. I think this is better. I hope this was helpful. If you have any questions, please feel free to come by and see me.